Hello YouTubers, this is a tutorial for Parallax Stage. How do you deal with parallax floor? This tutorial will only covers floor, will not cover other parts, and only cover one type of floor, which is trapezoid, which is a sprite looks like this. If you are using a sprite which is square or rectangle, this tutorial will not cover. You probably will search a parallax with width. This tutorial will only cover parallax with XScale. Okay, let's look out what if we just guess the number. What's the outcome will it be? So let's look at an example. In this example, let's focus on the left side of the reel, which is wearing the light blue. Look at his feet. Focus on his feet. So as you can see, his feet is sliding on the surface of this bridge. His feet is not obeyed Newton's law actually. Let's check the rope on the right side. Normally, when the rope travels to the center of the screen, the rope should be perpendicular to the x-axis of the screen, but now it's not. Now let's do some drawing and simple math to solve this problem. First, we have to draw a triangle like this. Actually, you just need the right triangle, but now we have two ropes as reference, so we can draw a triangle, then draw a perpendicular line to the cross point. Now we will have three horizontal lines. The first horizontal line, which is the top one, is the upper boundary of the sprite. The second red line is the line which player was standing. So basically you put your axis point on the second line. The third line is the lower boundary of the sprite. Then you are going to find your Photoshop or any other image editors to measure those lines. So my measurement is the first line is 79 pixels, the second line is 100, so it's quite lucky the second line is 100. The third line is 121. And what does it mean for these three lines? So basically, if it's in a 3D world, these three lines should have exactly the same length. So basically, if you walk through the bridge, for example, you're standing on the 100 line and walk through the bridge, your points will travel through this 100 pixels lines in a single time unit. And let's say you will travel through the second line, which is 100, in a single one time unit. So basically the time is 1. So for the top line and the bottom line is also the same. Basically you should travel through the top line as the bottom line at the same time. You spend one time unit to travel 79. You spend one time unit to travel 121. So now the distance is different, the time is same, and the speed, which is called delta in MUGEN, is different. So basically you want to calculate the delta value. The delta value for the second line, which reads 100, should always be 1 because the player is standing on this line. The player always have a delta value which is 1. So based on this knowledge, we can easily form a formula which reads 100 divided by 1 equals 79 divided by x. X is the upper boundary delta. And also equals 121 divided by y. Y is the bottom boundary delta. Now we can use some simple division to calculate x equals 0.79 and y equals 1.21. Okay, now let's apply our knowledge to our code. So there's one tip here. So if you look at the stage info section, the z offset is the y-axis, the y point where player will stand. But here I set to 0. Why is that? Because I have another parameter which is z offset link, which is set to 30. And I can see the 30 actually linked to the BG floor parallax. That means player will always sit on the floor. Player will always sit on ID 30, this background element. Player will always sit on these elements axis point. So there's no need for you to set Z offset. And if the BG floor parallax moves, the player's ground will also move. So you don't have to calculate anything. So basically leave it 0, leave the Z offset as 0, and then use this way. It will be much easier for you. And let's take a look at the BG floor parallax section. So let's look at the delta one. So the delta which have two values. The first value is the upper boundary move speed delta. Basically, if it's 0.5, that means if the player moves 2 pixels, this BG element floor will only move 1 pixel. It's a 1:2 ratio. But here the ratio is 0.79, which we previously calculated the up boundary of the BG floor. So let's move to the next parameter, which is XScale. So XScale have two values, but actually only have one value, which is the first value divided by the second value. It's just a ratio. Now I give it, which is 0.79 and 1.21. It's based on our previous calculation, but if somebody likes put the first value as 1, so if you calculate the ratio, the second value will be 1.5 something. It has exactly the same effect. So it's up to you to use the ratio like this, or use the ratio start with 1 and calculate the second part. Is up to you. Basically that's all. Once you settle down the delta and the XScale, the floor BG parallax will look just fine. And for this example, I have another floor sprites down under the parallax one. So the down one is linked and attached to the parallax one. It will be a normal. It will be a normal background elements. So its delta value will be the lower boundary value of the parallax element. So here the delta is 1.21, and then the delta value y, I will always keep it 1 because I don't know how to deal with the y yet. So that's it. After you settle down the delta and the x scale, you're good to go. And here is the result. Now our Rio looks like he is obey the law of physics now. And the rope now becomes perpendicular when the rope travels to the center of the spring. And when Rio fire a Dogen, because this Rio used the zone controller, his feet will not slide away because he is standing on the BG element. The BG element's axis point is on the BG element. It's not above or below it, so it will not drift. So you might think what will look like when you set the axis points above or below the floor, not on the floor. What will it look like? Look at Rio's feet. When he uses zoom, his feet will drift away. His feet will drift away.